and also some updates on the community. Then there will be Sachin talking about Linkerd. Then we will have some food, and Jussi will give an introduction in K3S, and Toni will talk about, well, container security. Okay, so we as a group, I think, like, how many newcomers are here? Have everybody? Okay, some newcomers.
Welcome.
So welcome, yes. So we are part of Cloud Native Nordics, and Cloud Native Nordics is also part of CNCF. So we are actually meetup groups all over the Nordics. There has been, we are, I think, about 13 groups. I think there is now one new one in Stavanger.
Yeah.
Yes. And well, we are trying to grow more and more. And we are also organizing tours for speakers through several meetups in the Nordics. So there has been, I think there has been Russ Miles and Alexander Sovitsky. They have been doing a tour from Copenhagen to, well, through Aarhus and Stockholm and Helsinki. And of course, yes, if you are interested to speak in several cities, I think we can organize that for you.
There's a fair amount coming up this spring.
Yes, yeah, we organized this, but I think we have to first set up the rules how we're going to do it, and it has been not so easy to communicate with all of the people, and yeah, some challenges.
So are you guys organizing it also in Helsinki, or there is a different group?
Well, Helsinki, it's Lucas actually who is organizing it there.
You don't go there.
I'm just there helping sometimes to stream. Yeah, all the time, yeah, helping out. But yeah, well, if you joined actually also the Slack channel of the Cloud Native Nordics, you can communicate with us quite easily. And if you want to speak or have any questions, how you can solve problems, I think it's a very good place we can help there.
Yeah, exactly. All of the cities are, so to say, open.
Yes, yes.
For whatever collaborations.
Yes, so these are the stats. So we are 12, well, actually now 13. I think this is a little bit older. And total number of meetups. So in the Nordics, 103 meetups were held, and we are over 6,000 members. And yes, well, that is actually the slide. Lucas and Kasper are missing from here, from this slide. Yeah, so in Helsinki, there are actually 970 members, and here in Tampere there are about 200, or a little bit over 200 members. So, and we are growing, well, not so much anymore as the first meetups, but we are still growing. And well, as we are part of CNCF meetup groups, we are following the CNCF and Linux Foundation Code of Conduct. Well, in short, just be nice and respectful to each other. So yeah, and then we also need your help. We have several GitHub repositories where we actually gather all the things what we are doing here in the meetup. So actually Lucas has just created a meetup kit for people who wants to run a meetup and gather all these stats what you have seen, and yeah,
all kinds of data for visualizing meetup.
Yes.
Somewhat other way.
So you can contribute if you want there, or you want to run your own meetup, just use that and try it out. I think there is even, like in Indonesia, there were some guys actually looking at our stuff, and they have actually used it and improved some stuff there also. So quite nice to see.
So does it not mean that the Nordics groups are on a
another
expanding?
Yes. And then also what is very nice is the workshop CTL. So we have been running, maybe not the last, but the meetup before, it was a workshop at Efficode, and we used this workshop CTL to actually spin up the clusters for everybody who took part in this. So you can also take that and improve it or try it out. Okay, so and then we have the website. It's here, you can see it's cloudnativenordics.com, and here you will see what are the news and
all that kind of data
yeah,
from the different groups, what they are
yes,
doing, what kind of speakers.
and of course if you have been speaking on one of these events, you will be also in the speakers, you will be mentioned there. And yes, so join the community, join the Slack channel and talk to us. I think we are very happy to help out in whatever kind of issues you have. And
We're live streaming. So
yes, we have also a YouTube live YouTube channel where you can actually see all the talks of all the meetups in the Nordics. I don't know how well Helsinki and Tampere and Turku, they are always streaming. I'm not sure how the other meetups, some of them are streaming, but yeah, you can check that out, sign up and subscribe for the channel, and you will have there the possibility to look all the previous meetups as well.
I guess there's also these the recordings of the community sort of planning meetings.
yes.
Those are also in the same channel. So.
Yes.
So with the Cloud Natives community.
Yeah, we are.
Maybe Nordics community.
Yes, we are meeting actually once a month, where we actually align all the meetups, what we are doing next and what are our plans. So yeah, so we are actually this is always problematic to find speakers about Kubernetes or any CNCF project. So whatever you have done, even if it's a small test drive, please come and tell about your experiences. If it was successful or not, just let us know. And the community is probably very happy to hear about that.
Especially if you burned down something with the Kubernetes or CNCF. Those are always the most interesting.
Yeah, the best stories, yes.
that doesn't exist.
Okay, so and if you are interested to host an event, so please contact us. And also if you have a speaker that could speak, so you will be mentioned here on this slide. And we have another slide, so if you are interested to be here, you just sign up on this page and you will.
Basically saying that you're using Kubernetes, so we're trying to figure out what kind of different Finnish companies are using Kubernetes.
So that we have a landscape of the companies that are active.
So we can get a view of these people.
Okay, so we are part of Cloud Native Computing Foundation, and well, most of you know what Cloud Native is, and I guess there is not too much to say about it, but it's a collection of open source projects, and there is a governing board that takes care of that these are compliant and that they are active. So, and then there is a 3-level staging of those projects. So you have like in Apache, you have a graduated state that Kubernetes itself and Prometheus and so on, they are already graduated, so you can trust on them that they are production ready. And then there is incubating projects, and there is also sandbox projects. Not that you cannot trust on them, but they are maybe still not 100% production ready, but they are in use already.
Or at least quite a bit on earlier stage in the adoption.
Yes.
Of the technology.
Yes, but
that's the main sort of thing.
And all those projects that are actually in those stages, they have a community behind and they are used. So they are not just random open source projects. So you can already trust on them.
If something getting the native to CNCF, I guess it goes to the snapshot projects, like in the beginning.
Yep.
Yeah.
So it can be something big actually and useful, like used by many, but it still just can be snapshot because of it.
Yes, yes. Okay, yeah, so these are actually all the projects. I don't know if this is the latest status of the hellscape of CNCF. So in principle, you can just make a pull request for CNCF and commit your project there, and it will appear here. And as you see, this is growing, and I mean every year or every month this is getting bigger. So it's not a landscape, it's a hellscape nowadays. Nobody knows. I don't know, just a few. And how can you find even there? It's crazy. So yeah, what CNCF does is actually it gives your company maybe a kind of a trail map how you can adapt with these new technologies. So, well, at the first stage, it's containerization. So you containerize your applications that have been previously running on VMs, and then you have to look at your CI/CD because it's a bit different than maybe the traditional way. And then, well, it continues with observability and until networking and yeah, how you actually distribute your software. But yeah, so this is what CNCF helps you a bit, how you can adapt to these new technologies. So yeah, what is cloud native? I mean, in our last meetup, we had actually a nice discussion about what does cloud native mean to you, and it has been actually quite fun because there are different point of views as we have seen, and yeah, we had even not argues, but it's like everybody sees it a bit different, and it's quite funny. I mean, for me, I have been just starting a new project, and yeah, what is cloud native? I think maybe also some people think that cloud native is you're doing cloud provider native stuff. So AWS native means cloud native, so it's quite funny because it just means the other way. It's not vendor lock-in, so it is quite funny to see cloud native. Yeah, you could think it of you do like only vendor lock-in stuff, but it's not that. Just want to mention that everybody knows that here, I guess. So yeah, but what is next in the conferences? There is actually in Amsterdam in March, end of March, the KubeCon Europe. So has anybody planned to go there? If I can ask. Maybe now. Okay, good. Sign up. And Oscar, I think you are also, right? You are going to KubeCon, yeah. And then, of course, China and North America. There is like, in Europe and China and North America, there is every year one of the conferences. And additionally, there are these Kubernetes forums, which is a little bit smaller. I'm not sure if it's a 1 day or 2 day track. And there's also the Cloud Native Nordics. We are planning to have a conference in Stockholm. I think it's maybe end of September or October. Yeah. And it will be a 2 days. I think it was a 1 day conference and the other day unconference. So if you are interested also, please, if you are interested to talk there, please come and join Slack channel and talk to us. I think there was about 300 people was the plan maybe to have there.
Something like that. Yeah, so it's called Kubernetes Community Days, and it's like, you can think of it as a mini KubeCon, but basically with the local vendors and the local people, as KubeCon has grown so huge these days.
And,
yes.
And organized by the community.
Yes, by the community, but not by CNCF.
Yes. Okay, and then mark your calendars. I don't have exact dates yet. So in Helsinki it will be March, maybe before the KubeCon.
Before KubeCon is the plan. Probably open space at Startup Summer is the plan. So just on conference people come there and figure stuff out.
Yeah, and in Tampere there will be in April, most probably in the second week of April after KubeCon. We will have it at Netom. So we have new offices, and yeah, I would like to show it to all of you.
So
There is Turku before, probably.
We have March as well.
So there is Anton and Lasse, they are from Turku. They are running the Turku meetup, and most probably before March, I guess. Okay, and as I said it before, please reach out to us. We are glad to help everybody with any CNCF and Kubernetes problems, if we can, yes. Okay, thank you. So maybe now we have a sponsor talk.
Yes.
So tell us, where are we?
Yeah, welcome. I think it's before getting to the meet, we have this short commercial break. But even before getting there, I think we could quickly tell about our office. So now we are in our innovation showroom, and you just passed our kitchen. So the toilets are just beside the kitchen, and then there were some before the kitchen. And the refreshments are found from the fridge, I mean the left one, and then there are some others in the open fridge there. And the bread will be served somewhere around 6 o'clock, and I think that's time for the break then. And I can then show you the places. But okay, then the commercial part. Aha. How do I use this? How did I? Yeah, this is some wireless thing. No. Okay.
Just duplicate your screen. Yeah.
Let's try it this way. Okay, thank you.
Okay.
So, welcome to Cybercom office. I'm Toni Ylenius. I'm one of the makers. The maker story is just that we are software developers as the others, but the tomorrow team is something in the future that we also try to think into the future. But maybe easier to let our commercial video show the thing. I'm almost proficient with Windows. So I need to exit this one somehow. Thank you. Has anyone seen this yet? One at least. Two, yeah. There are some, I think, 3 Cybercom makers with the hoodies here and 1 without. So reach us out if there is something you would like to discuss. Let's check the audio.
This
Yeah.
is the ultimate IT brand film. The visuals are chosen by an AI, which analyzed dozens of other IT brand films. Hello, I'm a deep male voice. Cybercom provides innovative IT solutions on a global scale. That's why this globe shoots out data. Pew, pew. We hope that this beautiful forest makes you associate beautiful Nordic nature with our company, because we too are Nordic and beautiful. Here at Cybercom, we like to keep our employees happy, and that's why all the paid actors in this video will be smiling, no matter where they are or what they're doing. And what does branding have to do with IT? Well, not much. But it makes for some great emotional footage. We have offices in all sorts of places, including Helsinki, Copenhagen, Stockholm, and Warsaw. But there's no skyscrapers, so this is Shanghai. We do not have an office in Shanghai. To us, coding is art. But according to AI, it doesn't look cool enough. So this is a painter instead. Our coders get adequate compensation for their work, unlike many artists. AI suggests that we should show a person wearing virtual reality goggles. I think he should be wearing a helmet instead. And these don't exist out of sci-fi movies. Oh dear, still so much data. We have to speed things up now. Taj Mahal, supercar, cute kids, woodworking, what ballpark, what's going on? Well, that didn't work. Maybe we should use the AI to actually do something useful.
Yeah, let's stop. Yeah, but that video was based on real data, and that was our commercial break. Thank you. So what was next? Is it directly to, yeah.
Let me put it up. Oh yeah, that thing. Thanks. I'll take that. Yes, cheers. Do I sound like that deep male voice? Or do I have to go more bass than that? All right, let me just plug in. Did try it before, so let's make sure everything is in order. Yes, yes. Okay. Okay, my name is Sachin. I work in Microsoft in Helsinki. Today I'm here to talk to you about service mesh. So how many of you have heard about service mesh? Okay, let's start there. Okay, most of us. So if you have worked in Kubernetes, probably you must have heard about service mesh all the while in the last year. How many of you have actually used service mesh, like currently? A few, like less than what people know, but a few of them have used it. So a few months back, we used service mesh with one of our partners. It's a large bank in Turkey, and they were moving their monolith banking application to work on top of Kubernetes. And since there were a lot of microservices, we used service mesh. I'll come to the reasons why. So now service mesh itself is quite a large technology, complex. There are many different service meshes. So we only used a subset of those. So today I'm going to go through what we used. That does not mean that there are not other features. There are so many of them that I can't probably enumerate all of them. Especially something like Istio, which comes with loads of features. In this case, I'm going to talk specifically about Linkerd, which is a CNCF incubated service mesh. I'm biased a little bit towards Linkerd because I feel that it works out better than Istio does, at least out of the box. Linkerd is simpler, it has lesser features, but all the features which I'm going to show you were the ones which we wanted, so we tended to use Linkerd. All right, so let's see. That's a talk. So just bringing all of us on the same page as to what a service mesh is. Writing distributed systems, is hard. It's hard to write distributed systems because of the fallacies of distributed systems. And over time, as we started writing distributed applications, we figured that, well, there are so many problems that all of us have to then solve. Let's abstract it away. And that's how something like Kubernetes came up. Like, we are going to abstract away all the problems which software engineers need to face. We're going to move it at one level above into a platform, and we're going to use some orchestrator to make sure that we don't have to deal with all of those problems. As you use Kubernetes and you use microservices, well, you don't even have to use Kubernetes. As you use some form of microservice architecture, some form of distributed systems, you will realize that the biggest fallacy of distributed system is that the network is reliable. Networks are not reliable. Things fail all the time. And in fact, going back to what's the definition of cloud native, in my opinion, it is expect failures. If your software works expecting failures, then I feel like you're cloud native, because we're going to work on unreliable networks, unreliable machines. Your software will go down, so can you make software which is resilient to those failures? In my opinion, that's what I call cloud native. So as we started to write distributed applications, even on top of Kubernetes and microservices, we realized that we need a better resiliency mechanism. We need something which will make sure that the services which we have now divided into many different, like we had a monolith before, now we have divided all that into multiple services. We need to make sure that the service can communicate with each other in a resilient manner. If something fails, we can gracefully degrade, we can retry, we can have timeouts. So what initially happened was that you must have heard something like Netflix OSS called Hystrix. So Hystrix is this library which lets you write resilient Java code on the JVM. So it provides things out of the box. So again, you don't have to make it, like retries and timeouts, what I was just talking about. And that works out pretty good. I mean, Hystrix is great. Then the question becomes, okay, what if you're not using JVM? Then what do you do? Well, of course, when there's good idea in one programming language, it always gets copied to another programming language. So eventually, people copied Hystrix all over the place. You have Go port for it. You even have Python ports for it. So yeah, I mean, if you write different languages, then you can just port one of those. So then the question becomes, okay, if my company is using in microservices, we tend to use like any language which your team feels is the right one for this purpose. So if we are going to adopt so many languages, are we going to adopt also so many different frameworks to make sure that the resiliency works out? Should we be solving these problems at our code level? Like, shouldn't we be dealing with business logic instead of network level concerns? So these were the kind of problems which eventually we started facing. We, as in community. So it's like, okay, we should abstract away all of these concerns, just like we abstracted away distributed systems concern into Kubernetes and figuring out the scheduler figures out where to put it. Maybe we should abstract away all of these network level concerns and put them somewhere else, so that we don't, like software engineers in our application code, are just concerned with business logic and not how to retry and how to make sure that things work in a resilient manner. So that's how service meshes were born. So service mesh is a network level software as an overlay over the top of your application, which makes sure that your services can communicate with each other in a more resilient manner. That's the original reason why service mesh exists. And by doing that, by using something like that, you can consider the kind of intended consequence. It's not unintended. Intended consequence of service mesh is you get lots of stuff out of it for free. You have service mesh, you can use lots of stuff which you would then have had to do on your own, like some manual method. Two of the most important things which come to mind for most people is mutual TLS, which I'll show you, like we used it, and network routing, like how you're going to route traffic within your cluster. So by using service mesh, you make it very easy to do MTLS and service routing, and the original reason for using service mesh itself, which is resiliency of communication between your services. So when we worked on the project with this bank, these were the features which we were mostly looking for. Now, if you go through Linked's documentation, you'll figure out there's loads of other features. So I'm not going to go through them. Maybe after this one, when we are having networking, maybe you can come and we can talk about it. Okay, so what is Linkerd? Linkerd is a service mesh, which is a CNCF project. It's in CNCF incubated. There are many different service meshes. I have used Istio and Linkerd. I've not used any other, but I'm sure they're similar in concept. So for example, HashiCorp's console comes to mind. Then, for example, AWS has its own service mesh on there. And there are loads of others like Mesh or something like that. Okay, so I had this talk in Helsinki once. So now how do you get Linkerd installed? Now, Linkerd is extremely easy to install even out of the box. It's like it comes with a nice command line tool. And you can just run it on to like Linkerd install and give it the link to your cluster, and it figures out, okay, what's in your cluster and what needs to be done, and it generates a YAML file, which you can then pipe to kubectl and just apply. So that works out of the box. Of course, you can customize it. If you were to go and work with, for example, your own certificate authority, you want to integrate your own certificates, or you want to use Helm, for example. In our case, we use this GitOps method, where what we do is, like, how many of you are aware what GitOps is? Okay, a few. So, okay, just going quickly. So instead of pushing the config using kubectl apply to the cluster, what we say is there is a component running in our cluster which looks at a Git repo, and any changes to that Git repo are automatically applied to the cluster. So nobody except the component running into the cluster has access to Git. nobody has a write access directly using kubectl on a production environment, so you don't want to share this credentials just to prevent the attack vector of what's possible. If somebody has actually, it can get leaked and somebody can input something. So everything is audited in Git. You have to make sure that things end up in Git with whatever method you have, like a pull request. And once it does, the component will just sync its state and will apply everything. So as you know, Kubernetes definitions are written in a manifest. So that manifest is generally quite big. In our case, we use a component called Fabricate as a high-level definition language. I'll show you an example when I go to the demos part. In which you write very easily what all components you have, and then it gets translated to manifest. It's not very important for this one, but I'll show you like how the Linkerd manifest is there, and it's part of the definition. So a new cluster, when it comes up, so it just reads from that Git repo and reapplies everything, and in this case, we'll install Linkerd because it's part of the manifest. So by doing something like this, it's very easy to spin up new clusters. Again, I mean, you must have heard this, the thing in the Kubernetes community right now, just like, do not depend on mono clusters, do not depend on one cluster and it being like your sacred place. Clusters should be easily, you should be able to remake a cluster. It's just like pets and cattle, yeah, so just had a blank. So it's like pets and cattle. Your clusters should also be like cattle instead of pets. And so if it's something like that, just makes it very easy. You don't even have to deal with the Linkerd client. Everything is in the Git, so it gets applied. I'll show it to you what I mean. It's not very important from this one. So, okay, so Linkerd itself comes as a small portion, so it's not one monolith which is running into the cluster. It has multiple components. For example, it has TAP, which looks at the network traffic. It has identity, which makes sure that you can get the certificates, and then that's how the mutual TLS happens. It has a service profile validator. Service profile is something I'll get to it soon. Anyways, I'll show you when I show you the Linkerd components. You'll see that it's divided into multiple components, and also you can run all of them in a high availability mode, which is then it runs multiple depending on the number of nodes. So of course, if you're in a production cluster, you run in a high availability mode to make sure that all of these components are replicated onto your cluster. Questions? Anybody has any questions till now? Okay, very clear. I'm not only deep, but I'm also clear. Okay. Okay, so how does Linkerd itself work? So Linkerd has this component running there. I was just talking about components, which is a controller which just is there to watch something like this. So when something gets applied to kubectl through the cluster or through your GitOps, anything which has like a deployment has this metadata annotation which says Linkerd IO inject enabled, will inform that component that, okay, this component seems like it needs, it wants to be meshed in. So it wants to be part of the network. So let's go ahead and add it to our mesh. So what that means is this is a sidecar. So your pods are, so the basic component in Kubernetes, as you know, is a pod. In this case, a Linkerd container is going to be part of your pod. So it's going to inject itself next to your container. Then it's going to run an init container, which will modify the IP tables of your container to route the traffic through Linkerd. So that's how Linkerd actually works. So it's quite transparent. You really don't have to do anything about it. All you have to do is apply this particular annotation to your deployment, to your pod, to your namespace, whatever requires meshing. And Linkerd will pick it up, and it will inject itself. It will modify the IP tables of your container and route everything through Linkerd. So that's the sidecar annotation. It's very transparent, works beautifully out of the box. And okay, so if you have something like that, you have a meshed network. So you have service mesh running in. So we're saying, like, just by doing that, like, just doesn't sound like Linkerd install kubectl apply -f. It should install all of the components. Things generally work out of the box. If your cluster is a bit special, you might have to do something, but more or less, it just works. Having done that, you get mutual TLS for free. Now, anybody who has implemented something like a credential system rotation would know how much work making sure your services can talk on top of TLS requires. You need to get certificates. You need to make sure that certificates are exchanged in some secure manner. You need to make sure that when the time comes, your certificates can be rotated. So there is a lot of work. You might have to install a certificate authority. Of course, Let's Encrypt makes it possible. The question is still, why do it? Like, why do it? So by providing something like this, makes it much easier. So there's this identity component running in Linkerd. When your service comes up and it says it wants to be injected, it talks to this identity component, it receives an identity. Every time a communication is going to happen through the destination component of Linkerd, it first checks the identity of the source and checks the identity of the destination to make sure that they are what they said they would be, and then the communication happens on top of an encrypted wire. So why do we do this? So in some industries, for example, banks in this case, you have a requirement that the data is not only encrypted on the disk, but it is encrypted on the wire forever. So you just cannot have plain text being going on. So for that reason, MTLS out of the box works out very nicely. So what we don't want is somebody having access to your cluster to inject a pod and then listen to the traffic of whatever is going on. Because lots of times what you have seen before traditionally would be your API gateway or your front-end gateway would terminate the TLS, and inside you are like, now you're inside, you're free to do whatever you like, so you're just sending in plain text. And if somebody was to inject a pod in there, something, then you can listen to all the traffic, what's going on, which is what we are trying to prevent here. So in this case, mutual TLS, just because of an identity component, just works out of the box, so you don't have to do anything. Linkerd will upgrade all connections to TLS opportunistically, so if it can, it will. If it has injection, if the source and the destination both have the injection, then it will just be provided by Linkerd opportunistically. Like, you don't have to choose anything. You don't have to say, I want TLS. It's by default that it will be TLS. I mean, I think I've never tried to not have TLS, so I've never tried. Maybe I think it's possible that you can remove it, but I'll be like, why would you want to remove it? Like, when it is provided out of the box without you working. I'll show you what is the reason I'm not switching between the two screens is it's such a pain to switch screens and then copy it and then go. So I'm going to show you all of this in one go. Okay, so this is the original reason why I was talking about service mesh, like reliable communication between your microservices. You have many different services. You want to make sure that one service can reliably talk to another, and if they can't, then they gracefully degrade. You can retry, and you can have timeouts. So this was the original reason. And Linkerd has good support for it. So retries, very easy. You can resist, again, some kind of Kubernetes spec where it says, for this particular route, this is the route which is which Linkerd can find out, because you're saying, okay, for this particular API/annotation, I want to say that it's retriable. So if somebody tries to hit this API and it fails for some reason, then retry it. Okay, so why don't we have retries out of the box? Because, as you know, not all calls should be retried. Not all calls are idempotent. So maybe we don't want to retry it. So that's why it doesn't come out of the box. Just like TLS comes out of the box, retries don't come out of the box. You have to actually write the service profile. So this is in Linkerd is called service profile. So for your service, you write some kind of profile which you tell Linkerd a little bit more about your service, and then you get these features from Linkerd. So in this case, as you can read, is if API annotation, somebody tries to get on it, and if it fails, retry it. So what you will see is Linkerd comes out with quite good metrics. I'll show you the dashboard soon. From there, you can figure out like what's the 4 golden metrics of my app. And in there, you can see that there is the success rate, which is the success rate taking consideration that it has been retried and how many times did it actually have to retry. So you can see both of them. So your client does not know that it got the response after a retry. So for it's successful, but Linkerd will note that it was a retry. So it will give you both the metrics as to what's the real rate of success and what's not. How many of them did require a retry. Wrongly implemented retries can have a serious repercussion on a distributed system. So what you can do is, you send a retry, it doesn't work, you send a retry again, and so it's called retry storm in distributed systems. So many systems are trying to retry, which leads to even more retries. So your system is becoming slow. That's why it's not able to perform. So you hit it with more retries, and it goes slower, and there is a whole degradation of the network. So to prevent these kind of things, you don't want to retry all the time. You can specify like, what's the retry budget? What's the ratio of the failure and the success I should keep track of? What's that ratio I must keep for my retry budget? So if it fills up this retry budget, then something is wrong with that service. So probably we should stop retrying it because probably it's gone down or something is wrong with it, it's actually not working. So let's start retrying the system. So that you can control with retries budget. If any of you use Hystrix, all of this will sound like, okay, well, all of this is exactly like, so yeah. Instead of writing all of this in the part of your code, in your business logic, we have taken up one level up in a service mesh and provided to everybody out of the box, or by providing a service profile for your path instead of writing code for it. Questions? Okay. Another similar concept as timeouts. So you try to hit something. You know, in a distributed system, the biggest problem is a failure is a good thing. Like, you know failure happened, nice. I know that something has failed. The problem comes out when the system just doesn't respond. And what do you do in that case? It's something like a timeout. Like I don't want to keep waiting for it. I want so that there are no cascaded failures. So your service depends on some service, which depends on some service. So it might be blocking a path there and holding on to resources unnecessarily. So in this case, you specify like, oh, I want a timeout for my call. If it fails, just return an error status and don't wait for it. Again, out of the box, something like Hystrix, but in this case, in a different layer. The biggest reason, okay, mutual TLS could have implemented myself, could have used Hystrix, or in this case, we were using .NET, so there are other libraries in .NET which are ports of Hystrix. Could have done it. Didn't want to do canaries on my own. So it's like two big features of service meshes are resiliency, which I just showed you, and network traffic routing. Like in this case, how do you split traffic between different places? Didn't want to do canaries on my own. Now, how many of you know what a canary is? What's a canary deployment? Awesome. So I don't have to go through explaining what a canary is. So you know, in Kubernetes we have a deployment. So deployment has a rollout strategy. You can set up max upsurge and how many minimum you want during a deployment. But it's still, after your all of your pods have come up, you shift the traffic there, and you hope that everything works out right. So that's the best we can do out of the box in Kubernetes. I mean, you just roll up a deployment, shift the traffic to the deployment, and hope that everything works out. In this case, couldn't do that. They're banking customers. Somebody's using your mobile phone to do something. You just can't go down. You know, like okay, let's hope that everything works out. So in this case, what we're trying to do is canaries. Again, for the people who do not know canaries, it's like instead of shifting traffic all in one go, we're going to shift traffic in small batches, so 5, 10, 15, 20%. And if it works out well, we'll have some kind of test there. And if it works out well, we will shift all of the traffic there and remove the old one. So that's what canaries mean. Since many of you knew canaries, this is what it just explains that, okay, we start with 5%, we have two services. Over time, we move all the traffic to there, and then that's how we have canaries. So there's a similar concept like blue-green. In this case, you have two different ones, and you shift the traffic between the two. In this, we have canary, so you're shifting traffic slowly. All right, so some time back, Microsoft, along with other parties, came up with this thing called Service Mesh Interface, which is the description of vendor-agnostic service mesh spec. So Istio and Linkerd both support some of the SMI spec. In this case, there's something called a traffic split. A traffic split is a SMI spec which can describe how you want the incoming traffic or whatever traffic to be split into two different parts. In this case, says, okay, in this particular spec, I want the backends, my website v1 and my website v2 to have 50% of the traffic each. So this is what the traffic split looks like. So this is kind of what is just a representation of what I was just talking about. You can say 5 and 95, 10 and 90, and over time you can shift the traffic. So this is what we are using when we are doing canary, so something like that. But in this case, it makes it even easier. So vWorks, many of you must know what vWorks is. It's a very popular company in Kubernetes. So vWorks came out with Flagger, which is a component which is running inside your cluster, which automates this process of writing the traffic split. So I could have done kubectl apply, and in every step I could have done 5, 95, 10, 90, and so on. It just makes it automated. So there is nothing special. It just provides a CRD, a custom resource definition, which is in your cluster, which is called a canary. It makes it easy to say, okay, any spec which has a canary attached to it should go through Flagger, and Flagger will wait for your new deployment to come up, and then use traffic split spec to shift the traffic on your behalf with whatever percentage you want, like 5, 10, 15, 20, or whatever. So It's just an automated way for you to do it. So again, the concept is service mesh provides traffic routing. Provides traffic routing using traffic split, which is an SMI spec. Flagger is a component which is running in your cluster to automate this process by providing a CRD called canaries. So again, by using service mesh and a few other components, it just makes it very easy for you to use something, quite an advanced deployment strategy like canary instead of rolling out everything on your own. All right, for the good part. Okay, quickly, let me first move this screen. I was just talking about, okay. The most difficult part is always moving a screen.
Isn't the Flagger having also like the logic of doing the shift, so if actually you have some degradation and you have some tests, checking that your new service is
very good point.
Problem,
yes,
that it doesn't actually go
absolutely. Yeah, absolutely, you're right. So I'll show you a spec and then I will show you a result. So first let me show you the result. So this is just of the logs from running a canary. In this case, you'll see, okay, some service has been updated. This service was annotated that it's a canary, so it requires a canary deployment. In this case, it says, okay, the canary were 10, 15, checking 20, 25, or goes all the way to 50, shifted all traffic, everything works out fine. So this is how you will see it. Now, how does a spec look like? Let me move this one. Quickly showing you the spec. Okay, hold on. It's a little bit difficult to. Okay, I have this application here. And it has a Helm chart. And so something like that, it has a spec for it. So this should make it clearer. So in this one, there is a CRD installed by Flagger. So if some component has this kind of spec, then it should go through canary. That's the point. So in this case, we define the spec as, for this particular deployment, this is the name of the deployment. What we want is to run this canary analysis for 152nd, and max weight is this. And what we are actually doing is we want to, when we, okay, so what we're doing is so we have this load tester running, and we are hitting a particular API, which we call automated test for canaries. In this case, we are hitting the base, the root URL. And what we are saying is 99% threshold for 99% of the request, we want to measure the request success rate to make sure that all of them are 200. When we are hitting this one, we want to make 99% in the 1 minute interval. So in 1 minute interval, 99% of the request must return 200. And if the canary, if your component is not acting correctly, there's some failure, of course, it depends on your test. Whatever test you write, in this case, this is just a demo test. Whatever case you has for your particular application, it will test your smoke test for your component. And if that fails, the canary would be withdrawn. So it says not enough metrics or not successful metrics for request success rate detected in Linked's metrics. And so going to roll back canary, and it will not do anything. So it will remove all the traffic, and it will go back to the original deployment which was running. So that's how it would work. Does that make it clear? Okay. All right. So.
I have a question.
Yes.
Can you spin up like a new pod there instead of the? I mean, if you want to run like end-to-end test something, can you spin up like let's say a job there with all your tests?
Yeah. Okay. Let's see. So in this case, there is a load tester which is running. In this case, I am running this pod called load tester, which is acting as a load tester, which is running your this. So you can run anything you like, as long as in the spec you have to provide how to run your test. It doesn't matter what's the method of doing it. In this case, I have this pod, which is called load tester, which is just a front end to Hey. You can use any of the JMeter or whatever you use, some form of load testing system or some other system or testing system. And you should have access to your this. You should be able to hit that route. And as long as the canary can access that particular pod, it should just work out. So yeah, you can spin up your own systems. In this case, I have this load tester because this came with demo, with the demo app. All right, quickly showing you, let's see, namespace, Linkerd. Oh, sorry, spelling mistake, Linkerd. Yeah, I was saying the Linkerd, unfortunately, it's a little bit off, so never mind. A few components like controller, destination, go ahead in the documentation, don't want to take too much time, but it itself comes with like a separate component. It's not running like a monolith as we would have not expected it to, like one single place where it fails. Okay, quickly I'll also show you a nice dashboard. Yeah, does it work? Oh, it is working, but not somewhere else. Sorry for that, I have no idea, that one. Okay, so it's like some dashboard where you can check different things about this. Again, I'm not going to go through it. It has these metrics I was talking about, the success rate. These are the 4 golden metrics for your particular application. In this case, it's the default namespace, which is this. It just shows you that there is a ingress controller which is hitting some service. So it's just this one. So like it's just a demo route. So it just does that and that. Since I hit that, it shows this particular edge. And again, I think Istio has much better dashboard. But then if you're just going for the dashboard, then probably there's something else which we need to talk about. Linkerd edges. Just want to show you that there is mutual TLS between the two. Well, this doesn't prove anything, but maybe I can reduce the size. Sorry, it looks a little weird. Okay, can I? Sorry for that. Okay, yeah, fine. There you can see. Okay, it's just that I just showed you an edge. That the ingress controller has an edge to service. So somebody, if you hit the ingress controller, the traffic goes to service and it returns back. And in this case, this check mark just is to make you see that it is TLS. It's this one. Of course, the real demo would have been I go and do Wireshark and show you that all the transfer. I'm not going through that. Just trust me. There it is TLS. Well, try it on your own. It actually works out fine. Okay, so those are a few of the features which we used from Linkerd. As I said, Linkerd is quite a large component, come with lots of stuff. Just want to leave you, I've praised all of this for Linkerd, just want to leave you with a little caveat as to what went wrong with us. Just want to make sure that you understand it, that just like any component, this also has problems. One, it's a different layer, which means it's not like you have completely abstracted things away. People still have to understand it. And it requires maturity of your team to understand this kind of thing. So what I have noticed is junior developers or people who are new to Kubernetes probably will use it wrong. So you have to make sure that there is a certain level of maturity which your team requires to use something like service mesh. It's a complex component, one. Second, a component like service mesh requires, like your Kubernetes cluster or your microservice architecture, any distributed systems requires serious investment into monitoring, like your observability. And if you have not made that, well, then it's only a matter of time before the shit hits the fan, right? So, and especially if you introduce a component like Linkerd, you require serious amount of work to be done for observability. So quickly going through, we had a problem with a DNS onto the cluster. Because of that, the identity could not be found for Linkerd, and all of the cluster went off. All of the services were fine. All the code was fine. It was just that the identity, the access to identity was lost because of problems in the config of DNS servers, so ndots config on core DNS. And because of that, we couldn't find identity. And since we couldn't find identity, all the traffic was denied because it was considered nefarious traffic. It was not considered, we could not trust it. So all of the cluster went down. And we did not have good enough monitoring for Linkerd itself to figure that out in time. So the cluster went down. So again, it's a very powerful component, but with all power comes cliched responsibility, right? So you have to make sure that you have serious observability, and you have to make sure that your team is mature enough to absorb a component like service mesh. And that's all. Do you have any questions for me? There we go. Yes, Anton.
Good question.
Yeah.
How much, like, if you want to run Linkerd locally, this whole local testing, like you spin up K3s or kind, how much resources does it take out of the box?
Lesser than Istio.
Yeah, Istio is 12 gigs, I think.
Yeah, exactly.
So it hugs your computer.
So Linkerd version 2 was written, I can't vouch for like how many megabytes or something like that, but substantially lesser than Istio 1, and substantially faster than Linkerd version 1. Linkerd version 2 was written with Rust, has serious performance speed up, you can see. And in fact, I would say that the proxy is really low. All the components are plugins, so you have to install and use them. So if you're not going to use much, I think the current system is, the proxy itself is, it's very, very small. It's really small. It doesn't take much effects on the resources. But again, I can't vouch for it. You will have to do your own test. I'm sure if you're running like a large cluster with 1,000 nodes, for example, things will be different than just running on a machine. So it requires more work. I have not done that work, so I can't vouch for the numbers. Yeah. One more.
I'd like
yeah.
to just add that Flugger has pretty neat integration with Slack and Teams,
Yes.
so you can
Yes.
actually see the updates.
That's correct.
Happening from there straight.
That's
away.
correct. Yeah, and of course, Weaveworks has very good integration with Weave Cloud. And if, I was talking about GitOps, for example, and we use Flux in this case, which is also from Weaveworks, which you can send to Weave Cloud. We didn't use it because we were using the open source version, but they're quite well integrated if you go with that route. Any other question? Yes?
So how this works with WebSockets? Is there any problems on that?
I don't understand why, like, where do you see WebSockets, in fact, as the point? So this is service-to-service communication inside your cluster. So are you assuming that one service is talking to a cluster, talking to another service over a WebSocket?
Maybe just in like hypothetical.
Yeah. This is supposed to be for client response, so I don't think it's intended, like service mesh is not intended for WebSockets at all, because you're proxying through another place, so which means maintaining two connections, like long persistent connections. It's not how it's going to work out. I haven't tried it, and I don't think it's intended for that purpose. So no, this is for request response. Again, this is a very good point. It's also not intended for event-based systems. This is only for something like HTTP. So you're using REST, using gRPC or something like that. This is only intended for that. It's not intended. Lots of microservices system are based on events. So this is nothing to do with events. This is just for service-to-service communication, and not on WebSockets. I've not used it. Can't stand for it, but I don't think technically, if I think about it, it's going to work out. Because
it should work out.
it should work out, okay. Well, I haven't tried it. Also, you can, like, if you don't want some traffic to be routed through Linkerd, you can provide an annotation and say, okay, skip the traffic which is going to a particular port. For example, your MySQL or whatever database you're using port. So you don't want that to be routed through Linkerd. So you can skip all of that.
So if you don't provide an annotation itself, I guess then it skips.
Yes, it will route. So the IP table routes is for all the routes, all the ports, everything which is going out of your, yes, would be routed through Linkerd. So you will have to actually provide, I don't want this to be routed through Linkerd, and then it will not be, yeah.
Maybe another thing also to add, like what you were saying regarding the service mesh, like what are the problems? Don't use it if you don't need it. It's like for the microservice.
Yeah, that's absolutely a very good point. So the reason, as I was saying, like, could have done mutual TLS on my own, could have done service retries on my own, didn't want to do canaries on my own, so that was the main reason we used it. If you don't have a reason, certainly don't use it. If your team doesn't have maturity, do not use it. It's a powerful component with a serious amount of investment required, but it has a use case. So if you do realize that you have a use case, I would go ahead and use it. But of course, like any good software, first you have to make sure that it's a component which you actually require. Yeah, please.
What is the cost of running it? Because TLS gives a little bit of an overhead, and as far as I know, I looked it up just right now, it's not using privileged mode, so it can't run in data plane mode. So it can't bypass the kernel.
Don't know what you...
Directly into user space.
Yeah, absolutely. So it's just running, so out of the box, it comes with its spot security policies, which will only be applied if your cluster has PSP running. Otherwise, it just needs inet admin and a few of the policies to route the IP tables when it's starting the init container. It does not run in a privileged mode, and it will just route it through. So, but yeah, any MTLS system, it will have a performance impact because you're doing more stuff than you were doing before. But it will be exactly the same, or I think this will be better than you rolling out your own one, because I think this is more optimized. But it will certainly have an impact. So if you don't need it, don't do it. In this case, we needed it because it's a requirement of not to have any plain text communication over your cluster. So in this case, we do it ourselves, or we use something which comes out of the box. But there is a performance hit, absolutely, absolutely.
Would you opt out from the using
I was just saying that. So Linkerd will opportunistically upgrade every traffic. I did not opt out, so I don't know. Most likely, yes. Must be some annotations there which says I don't want to do any TLS. I have not tried it, but I think it could be there. Yeah. Yeah.
Can you manage ingress and egress from the cluster with Linkerd?
Yes.
Or is only for internal?
No. As I was just showing you, the edge was between the ingress controller, in this case Nginx, and a service. So you, Nginx itself has been injected with Linkerd, so it is part of the mesh. In this case, yes, if you know that Nginx will not pass the source headers onwards after it terminates. In this case, you have to provide some annotation and ask Nginx to also provide the source. Otherwise, since it works on host-based routing, it needs the proper host name to route anywhere. So in this case, you have to provide certain specific annotations to Nginx to make sure that the whole mesh system would work. Otherwise, it will not work. You will have to do that. But it works fine for the ingress.
Can it also support egress?
Yeah, egress is something completely different. This communication is something which is coming into your cluster and part of your cluster. Egress policy should be maintained in its different system. So yeah, we can talk about it later, but that's not necessarily part of the service mesh. I think I'm going to stop now. If you don't have any questions, let's do it later. I want to take a break and give other people a chance to talk later. Yeah. Okay, but thank you very much. Yeah.
There should be.
Okay, so there is some food in the kitchen.
Switch laptops.
Yeah,
right.
Yeah, go over.
Shall we roll?
Yes. One thing before, if the mic is already working. So I put there, behind you, a discount code for KubeCon in Amsterdam. So you get 15% off, which is 870 euros, something.
The off part.
Off, yes. With that discount code. KCU20, MU50. So, hope to see you all there. But I gotta leave for
All right.
Helsinki, so.
Thank you.
See you later.
See you.
All right. So those of you who haven't seen me, I'm Jussi, and I'm an sorry, wrong place. I guess quite many of you have heard about K3S. Anybody haven't heard about it at all? Couple of hands, okay. So yeah, so this is actually based on my sort of, I had some free time at my hands during during January, so I played around with K3S a bit. So this is purely based on my sort of just having fun with it and nothing official or anything. So so I'll show a couple of slides that what K3 really is and what it means, and maybe some ideas why you might care or should care. Should you care? I don't know. It's up to you. And it's 5 less than 8, so it has to be smaller, simpler, maybe. Let's see. So yeah, K3S is really a sort of a distribution of Kubernetes. So it's an distribution in a sense that it's really conforms to the certification tests and everything. So what you get with K3S is still K8S, sort of, at least. What it essentially means that you as an end user deploying your application, you probably won't see the difference. So it's still full-blown Kubernetes in a sense that it has the same API, it has all the same controls and everything. There's some bits and pieces modified underneath the sort of hood. And the main thing is that it's much more lightweight than a normal Kubernetes. I'll go into the details in a couple of slides. And maybe even the most important thing, as it's built as a more lightweight version of Kubernetes with some opinionated choices, it actually might have lower cognitive load for you. Basically meaning that it's much simpler to operate. And being simpler, more lightweight, it has a lot of great use cases like edge, of course. If you think about the edge and the sort of people going towards the like true edge, running computing on a light pole on the street, you won't want to run a full-blown Kubernetes with etcd and everything on a light pole. So and for me, one of the really sort of interesting use cases is like test environments. So say you run for your application, you want to run some integration tests. You might want to spin up a cluster to deploy everything into the cluster and run some integration and end-to-end test cases. So to boot up those clusters easily and quickly during the tests would be one nice use case for K3S. That's at least one of the cases I'm planning to use it for. Let's see how it goes. But essentially, because it's certified Kubernetes, so you can use it for anything. There's no limit on the where you can use it. But of course, as with the service mesh, you first have to figure out that you actually need Kubernetes. So. All right. So I actually borrowed this image from the K3S.io website, which has all the official documentation and everything. So, and by the way, the K3S stuff is actually coming from Rancher, but it's full open source Apache 2 license, so there's no Rancher proprietary licensing or anything. So, and the mastermind, as with any Rancher stuff, is of course Darren Shepherd. He's the mastermind behind the K3S. So, from architecture point of view, it's pretty much standard Kubernetes. You have your API server, you have your schedulers, controller managers, and whatnot. On the worker nodes, you have kubelets and everything. No big difference there. But if you actually look at the picture, so there's this boundary being drawn like a process. So one of the things that Darren actually started with was to bundle everything within a single process. Rather than running everything like in standard Kubernetes where you run it, on the master nodes you have many different containers running. One container for the API server, one container for the scheduler, one for the controller managers and whatnot. So in K3S, everything is actually a single process. And that part only, it already shaves you like a few hundred megs of memory use, just by bundling everything into a single binary and a process. And the same goes for the agent, the worker side. So all the kubelets, Flannel providing the CNI, the networking capabilities, everything's bundled in the same process. Again, shaving sort of unnecessary overhead. And I guess this is what makes it highly opinionated, because, well, you can't really go and change Flannel because it's baked into the process itself. On the worker nodes, the containers, the pods are running with containerd. I'm thinking, can you actually even swap? I don't think you can even actually swap it out, so it's sort of not really baked into the same process, but sort of highly coupled in a sense, at least, as far as I remember. I'm not 100% sure, but doesn't really matter. From architectural point of view, one of the super cool things that's part of K3S is also these tunnel proxy components. So in a normal world of Kubernetes, both the kubelet and the API server, they talk actually back and forth. So you have to have pretty much connectivity on both directions. And now when you think about use cases like Edge, when you have some workloads running on the light pole on the street, you probably don't want to have a sort of open API on a light pole somewhere that the API server from some random place in internet can actually call to. So what they came up with is this sort of a tunnel proxy component. So basically when the worker node boots up and calls home the first time, the proxy component actually opens up a connection to the API side. And that tunnel is used as a bidirectional communication now. So now the worker node in a light pole can actually sort of punch open a tunnel to the master node, and that is used bidirectionally now. So that's actually super cool. So you can basically run your worker nodes anywhere. I can run my master basically on Amazon and the workers on my Mac, for example. That's super nice. Another things that are sort of shaved off on K3S is quite a bit of the sort of third-party storage drivers United Kubernetes, it supports like 20, 30 different storage drivers out of box. People don't really use those. And we're anyway shifting towards using CSI as the storage interface. So basically shaving off that. I think Darren mentioned the line of code number somewhere, but it was a huge number of line of codes that they just delete. And same goes for the third-party cloud providers, because Kubernetes still has baked-in support for Amazon, Google, Azure, and something else, OpenStack and whatnot. And most people don't really use those. And again, we're sort of going to a direction where these cloud provider configurations and plugins are actually sort of external and not really baked into Kubernetes binaries itself. But well, we've been doing this in Kubernetes for the past few years already, and still we're not ready. So I don't know when it's actually going to happen, but let's see. Maybe technical point of view, the biggest change is actually changing the data store. So standard Kubernetes K8s uses etcd as you know, which is, how would I put it nicely? Not so nice, always. It's super complex. Of course, it has to have, like, it's a distributed, highly available data store with strong consistencies and everything. So it's not a simple problem to solve. So, but especially if something goes wrong, etcd is a pain in the ass to fix. So by default, K3s uses a SQLite, which is like single file. That's pretty easy to take backups and everything. It can actually work with basically any SQL database. Yeah. So yeah, something sort of enhancements that compared to like standard Kubernetes, that the reverse tunnel, I actually praised it quite highly already. And then as sort of part of K3s, it's actually separate sort of a project, but sort of born with K3s is the project called Kine. That's the sort of etcd shim. So something that sits between the Kubernetes that of course expects to talk to etcd. So that's sort of hard-coded in the Kubernetes at the moment. So you put this sort of a Kine shim process in between, which then sort of translates the calls to etcd interface from Kubernetes and translates those to a SQL calls, more or less. So that's a separate thing now, and the Kine has backend implementation for SQLite, DQLite, PostgreSQL, MySQL, maybe something else, but at least those four. So you can now actually spin up an Amazon RDS and use that as a data store for your cluster, which is pretty nice. They've also made this all these binaries as sort of these multi-call busybox binaries, which basically includes everything that Kubernetes and every component needs to operate, like IP tables and whatnot. Which essentially means that you basically have to get single binary onto your server and you can do everything with it. You don't have to figure out that, okay, I need up to get the install IP tables, this and that and this and that, and wow, shit, I have wrong versions. And you always have right versions because it's a single binary. And this single binary can do everything, like bootstrapping the clusters and everything. So that's super nice. Is everybody else noticing that we are actually seeing a sort of a, not really a new anymore, but we're seeing a trend in cloud native world. We're building tools, specific tools for specific jobs now. Like Linkerd had specific tools to set it up and everything. We have EKSCTL, we have this and that. Nobody is using anymore these general purpose Ansibles and whatnot. We're building specific tools for specific purposes. Just as a side note. Couple of other things. So, especially for these edge type of cases where you might even might not have an internet connectivity, there's a manifest and image auto deployment mechanism. So, on the master nodes, or basically any node on the cluster, you have special place like var lib branch or something, where you put the tarballs of your images and it sort of automatically imports those as usable on the containerd. The same goes for manifests, and not only pod manifests, but basically any Kubernetes manifests. So basically it runs like kubectl apply, whatever it finds on the local disk. So you can sort of pre-bake your products or whatnot with this, which is nice. And of course they had to do their own cloud provider implementation to get the external IP address in place for the nodes. Flannel for CNI, network policy control supported out of box, baked with containerd and runc, of course, has all the CNI CSI interface binaries in place. Ships by default with traffic for ingress controller, core DNS metric server, the usual things. And everything is baked for AMD 64 and ARM, like for Pis and stuff, which is nice. All right. And I'm trusting on working internet on my demo, of course. Yes. All right. So for the demo, I'm just spinning a couple of nodes up with Terraform on Hetzner in Helsinki. I'm super annoyed because Hetzner says that the data center location is Helsinki, but it's actually in Tuusula. Yeah. That always annoys me. Apply. Yeah. Hetzner is super nice for demos and everything because it's super fast to provision. Terraform is ready now. All right. So, to spin up the K3s cluster, I'm using a specific tool for that called K3s up, pronounced like ketchup. Ketchup is actually initiated by Alex Ellis, the guy behind OpenFOSS, serverless stuff, and a bunch of other cool things. It's just a little helper to get the correct binaries in place and configure stuff, and nothing super complex or anything. And now on the K3s ketchup terms, install means that I want to bootstrap the control plane. Just copy paste the IP address. It basically takes an SSH connection to the provided IP, runs a couple of scripts and downloads the single K3s binary itself and executes it, and like in a minute or so we'll actually have our control plane up and running. Yep. kubectl get node. Not ready. Not ready. What? Now it's ready. Yeah. So that's pretty fast, right? And then let's join the worker node into the cluster. K3s up, join -IP. So we have to give the IP address to which one we want to join into the cluster, plus to which cluster we want to join it in. Server IP. So basically, it connects first to the server, the control plane server, takes a special token from the server and then uses that token and joins and whatnot. Voila, my cluster is up and running. Just quite fast, like 2 minutes. Well, it's a cluster. But of course, one of the good things with K3s is, and sort of one of the best things, that it's still conformal to Kubernetes. So I can do whatever I want. I can do with kubectl on normal Kubernetes. It's the same API. So I don't have any special demo applications or anything. I didn't want to.
So it doesn't fetch the images from Docker Hub. So you need to specifically like build it and put it.
Of course, it can pull images from anywhere.
From anywhere.
Yeah.
Okay.
It's a containerd is a standard container runtime implementation. So
automatically it takes them
from the disk. Yeah, that's sort of a additional feature of K3s. Yeah.
Is this running any services as pods? I mean, any infrastructure services?
Some. Some, like metric server, core DNS traffic, which comes out of the box. Of course, you can go and disable traffic and everything if you want, but as you saw, I went just with the plain defaults, because defaults are good.
Is this kind of like a 2 nodes, or can you add another master, or it's just?
I can't actually now add another master because I went with the defaults, and the default is to use the SQLite as the database. And SQLite is like a single node thing. But it does support DQLite out of the box, which has this RAF protocol sort of on top of SQLite thing. But of course you have to install the first node with the DQLite too. But definitely you could do it.
But kind of worker you can just add if you just
Yeah.
join.
Yeah. So now if I would go to my worker account, no, I don't want to open the wars file because there's my secret token and we're live streaming, so. I've done it a couple of times and it's not a good idea. Trust me. But yeah, K3s is super lightweight.
How new is this?
It's been around since last summer or so, I think.
It got released last KubeCon, but it has been around before that.
Yeah.
But they
Yeah.
announced it, or like in version 1 to 3.
Yeah, I think Darren worked on it mostly like in summertime and then got announced in around last KubeCon, like officially. Of course, everybody knew about it already, but sort of. Yeah. One of the things that people have been asking, like from Darren on his talks and a lot on Twitter and everything. So now we're running the data store as a SQLite. So what about scalability? Can I scale this to 1,000 nodes? And Darren says that yes, and I trust him. He actually says that with the SQL database as a backend, it should scale even more than with etcd. I don't know, I haven't tried, but I trust him.
So you mean SQL as a SQLite with my one master node?
Yes.
Only.
I don't know, I trust him.
So like in that case, why is the recommendation to use it like for the testing and not like for a production use case? What prevents you from using it in production?
Nothing. As I mentioned, you can use it for whatever. It's like as far as the sort of official documentation said, it is production quality. Yes. But I mean, as you saw, I did everything by hand. So if you do a bit of scripting around that, you'll get the cluster bootstrap time to a minute. So that's a good thing for test cases. So when you start to run your actual tests, put up a new cluster.
So how about, like, for example, if the thing you were mentioning about the cloud provider things that it's like stripped off and so on, like you think about like virtual kubernetes and the implementation of it, like these virtual nodes and that kind of for auto scaling. So all that needs to be done by yourself in that case.
Yeah. But
they still support like virtual kubernetes kind of.
Yeah, I guess it should. Okay. It should. And yeah, of course, you still can use these cloud providers. You just have to provision those components yourself because they are not baked in now into the API server and whatnot. But I saw some discussion on the K3S issues that they might have to take some of those back in, but I don't know. I haven't been following that closely.
So it also has the Helm, I guess, by default.
Yes, yes. And actually, for the Helm, just kick me out when I'm too much overtime. So for the Helm part, actually they did a sort of Helm controller and a CRD type. So you can actually now, if you want to install a Helm chart, you actually describe what you want to install in a CRD resource, just push that on the API. There's this controller component running which applies everything, which is kind of nice. Plus, yes.
Yeah. How much memory do you need on the worker nodes?
So these are the smallest ones that I get from Hetzner, and they are like 1 CPU and 1 gigabyte of RAM.
Can you do it with less?
Yes. 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 So I think by default it takes like 100, 200 megs. Okay. Like versus K8S takes like 100, 200 per process.
So how do you see, is this kind of going to kick up Minikube kind of, because that's
probably
we use as testing kind of.
Probably.
This looks much.
And there's actually even K3D. Have you guys ever heard about Kind? Kubernetes in Docker. So you can actually run the control plane and sort of virtual nodes on Docker containers. So K3D is like K3S on Docker, local Docker. Yeah. Inception, how deep you can get. Yeah.
Would it then make sense to, for example, run this in Linux containers and have like one container be master one and then few containers be nodes, and then you can see what happens if you kill off a few nodes and see.
Yeah, that's exactly what sort of the K3D does.
Okay.
Yeah.
But it aims at Docker containers, not Linux containers.
Oh, yeah. But I guess it wouldn't be a big thing to, I mean, conceptually it's pretty much the same. Right.
How do you expose the load balancer in it? I think you mentioned it, but what is the IP address that is exposed, and does it expose every time a new IP? So when you have a service load balancer, what is it exposed?
Service load balancer. Oh, yeah, you mean a service type of load balancer, yeah. So K3S has actually baked in concept for load balancers, and then it actually implements load balancer type services as sort of node ports. So it has this sort of baked in Clipper component.
So how do you hit your cluster from outside? Like?
You have to hit through the node port.
So you need the node IP addresses. So
yeah.
It's, okay. So it's a standard problem like we have on-prem.
Yeah.
You don't have any load balancers.
Yes. Okay. Yes. But of course I could go and install Metal LB or something and Which, as I said, it's still a standard Kubernetes, so you can use whatever solution works. But much more lightweight and simpler. Right. I think I'm out of time.
One maybe comment, like what you were saying regarding like this combining everything as one module, and there is a trend going towards it. Like there is looks like trend for migration from the microservices towards some kind of like monoliths nowadays, like what Istio did as well. So is this like kind of like bundling things together and like in a way not giving you possibility to change it?
No, not really. I think this is more about efficiency and getting things more lightweight.
Were there those the same components in use from the beginning, or it has been updating and changing?
It's been the same stuff
from the beginning.
From the beginning, yep. As far as I know. Of course, I haven't been following the code base that much, but. All right. Thanks.
Are we having a break? Break?
Yeah, I think there is no break in the schedule.
There's no break.
How long do you need?
No.
Okay. Yeah, that was a great one, and I think the discussions are the best. And yeah, this having the last talk, it's not an easy spot, as we are all tired. And I also ended up preparing demos, so that we are able to keep awake. But yeah, preparing demos, let's see if I don't end up debugging live, but that's not an issue, but still. So, okay, now I'm sharing.
That's always fun every now and then.
Yeah, that is. So, my talk is about vulnerability scanning of containers. So, containers and security. I ended up doing this, I did a research in the end of last year. There was a request from customer that, okay, we would like to do this vulnerability scanning. Okay, I did a research, and I'm happy that I was able to do that in my work time. But it is as previous presenter also mentioned, that this is not official. This is my learning experience, but I believe that there is something valuable. And let's go through the findings. So, but before getting there, I like to start with the context, because I'm a DevOps guy, so to say. So in a DevOps, the pillars are the technology, that meaning that the tools like build systems, Ansible, all the tooling. And then there's the practices like how the teams work, how the Git flows and so on. And then there's the culture part, how to break the silos. So now we are discussing more about DevSecOps. So we add some more words there. That means that in this case, the culture part is that now in the DevOps we integrated the Dev and Ops. So in DevSecOps we integrate the security people in the same mix. But of course, in technology side, that means that there needs to be new technologies, because in DevOps world everything goes faster. So in security sense, also the technology change. And also the practice is so that we are able to evolve this whole system faster, because everything changes so fast. But this is just to give the context. So now we are discussing about the DevSecOps. And then one step down. So this is the overview, that in the left-hand side we have the dev, there is someone coding, and the right-hand side you have the ship, so something goes to production. And in the middle there is the build and something test and so on. And today we are discussing more about the registry vulnerability scanning and library vulnerability scanning. But of course, just to give the context, in the security there is also, if you are in the production, it's more dynamic. There is someone could actually breach your system, There are the audits, and you can do more dynamic things, also automated. And of course, when you're coding, then you have the other toolings. So now I'm going to discuss about the containers toolings. That's somewhere in the middle, because now if you're coding, then you have tools like you can analyze your code that you're writing. And now, then you put it to container, and then this discussion comes in. And then there is also the nice concept of policy management. So like policy meaning that, okay, what is acceptable, how many vulnerabilities can we let to the production, and so on. And what ports can we use, and so on. So this is also the context. So today, next I'm going to jump to the demos. So security vulnerability scanning with tools like Claire and Encore. So how many of you have heard about Claire? Less than half. So I guess that not that many have used it, or any? 2, 3, great, 4, maybe the same people. And the next tool will be Encore. Is that familiar to you? 2 ones? Good? Okay. So I will show you how the Claire works. The Claire is quite simple, and maybe that's also the best part, because Claire is used. It's easy to integrate, and that's the reason it's used for if you, for example, use GitLab paid security product, it will use the Claire as one component. Then the Amazon ACR scanning uses this one, and then also the Red Hat QA, their container registry product. It's using this one as the security or the scanning product. Okay, let's jump into the examples. Oh, the same issue as with the, sorry. So I didn't mirror my screen, I see. Not yet. Are we now getting it? Yeah. Does it cut? Not bad. Yeah. So on the left hand side I have my examples. So I'm running now Claire as a Docker container. Claire is it's a service that you start, and that uses database. So I have run these already, but we have Claire configuration, and then we have Postgres container as a database, and then we have the actual Claire container that we will contact in these examples. So Claire is simple. You just push your local images there. So this CLAR is one of the Claire compatible tools, and when you run this, it will get that container image I provide, and then it will push it to Claire. And Claire just simply gets the layers. So for example, we will now push the first one. It will get the, it already has the layers, so I'm scrolling up. There are quite many. Where is it? Okay, maybe we will check it on the next one. So I gave, for example, an old Postgres container there, and then it lists a lot of vulnerabilities. Okay, some of them are critical, and then there are different levels. And then let's pick the latest one. These are fast because I already tested. Oh, there are some. But let's now scroll the up. Maybe I will make it smaller. So it will it will analyze the layers, and then it will print out the findings. And the findings, it gets the OS vulnerability feeds, like Red Hat provides feed, and then Alpine provides feed, and then Debian provides feeds, and Ubuntu provides feeds, and then it combines them in the same database and compares that with what packages are installed. So the principle is really simple, and that's the way it works. But the issue is that, for example, Now I will put it a bit larger. If we pick Alpine 3.6, now vulnerabilities. Let's pick Alpine 3.7. Okay, there is one. There is something broken with the feed, so it doesn't show the CVE and the description, but there is a vulnerability. So what's the issue here? Because now the more earlier one has less vulnerabilities than the new one. Let's write 10 here. 0 vulnerabilities again. So anyone guessing? So the issue is that Alpine feed doesn't have the vulnerability for the older version. So the main message is that you need to understand how the system works. And in this case, it is just using the feeds, nothing magical. So if the upstream provider doesn't mark this, for example, in this case, the Alpine 3.6 as vulnerable, then this won't show it. So you need something else also. And the another note is that, I'll quickly show that, for example, okay, so, even in CentOS there seems to be some, but it's also one of the issues and findings that there will be a lot of these. So there is a lot of noise, and I was about to show, yeah. I will scroll up. There are, in the CentOS we had 7 high, and let's compare the Debian. There we had 45 or 46 findings, and was it 7 in the CentOS? Yes. So this is also the second point to understand, that as I have in the slides, the Debian is the most supported one, but that also means that there will be more noise, and then the RPM is somewhere in the middle, and Alpine is, as I mentioned, it depends on the upstream.
Yeah, this is kind of what you noticed, that some of these feeds are not as kind of trustable as, or kind of
no. Yeah, and in fact, it was not only me that found it, because that is one of my revelations, that, and I dig quite deep and try to understand what is the difference between these. And the difference is that, for example, Debian marks, for example, Red Hat doesn't mark, if the vulnerability is not fixed, it's not marked. So there might be something vulnerable that is not fixed, and in Debian they will mark that this is vulnerable even if it's not fixed.
Yeah, I was just thinking, because a lot of images are based on Alpine.
Yeah.
Of course, it's lighter than Debian, or
yeah.
so that is kind of a little bit the cut down in the use of this Claire tool. Kind of, that's the first look, that if you kind of, at least if I think about the container that we are running a lot of based on Alpine, so I would probably get some kind of.
Yeah, I have more examples with Alpine later, so I still wouldn't call Alpine it's worst in this sense.
Yeah.
But if you use the latest version and you understand what you do, then I think it's okay. Then the next is the Encore. This is more later one, and this has more into it. So for example, it also does some checks from pip and npm that what Python and Node packages are installed, and then compares that to some feeds and gives more vulnerability findings. And then it also can check, for example, if there are secrets stored in the container, and it can report that. And then the third, maybe the one that they are trying to advertise is this policy. So it first does the analysis, and then you write the policy that, okay, for example, as I mentioned that, for example, you are not allowed to install SSHD on this container, and then it will mark it failure if there is something that doesn't match the policy. The Encore is such that it's similar, so that you have an Encore running, so that's a service, but in this case Encore you have like five containers instead of 1 or 2 in a Claire. So let's check Anchor quickly, and then I have one more example in the end. So to get the Anchor running, you follow the documentation. It's like this. I have it already running. I think I have sorts these, and these are the default passwords and so on. I'll put it there. I also have did this, so this image list will show something. So there are images that have already been analyzed. But to analyze image, we do something similar, so we push the image there. In this case, I guess it works so that the Anchor gets the layer. And in fact, I'm not sure, did I say something wrong about the Claire, that I'm not 100% sure which one pulls the layer. Is it the client or the server? It's the server one, yeah. So in Anchor, it's also that you provide, for example, this image is stored in a registry here or there, and then it will get that one. Okay. Maybe it's getting the new version, I don't know. I don't want to wait. We can check the old vulnerability result like this. And it will show, this was 3.7. Yeah, this was the one that also showed the vulnerabilities in the Claire example. And in this case, we can see that it's this user library that is vulnerable. Let's check, for example, the 3.6 that we discussed before, and there is the same. Also, the Anchor doesn't show the vulnerability because it is using the same feeds, and in fact, this Anchor is so nice that we can, for example, see the feeds and their status. Let's see. Probably you can't read it, but there are Alpine, CentOS, Debian, Oracle Linux, Ubuntu, and then there is Amazon Linux also, and so on. And then they usually contact this CVE database to get the descriptions for the vulnerabilities. So these work similarly in this OS package scanning. And then quickly the policy part. So maybe I'll do this if you're able to read it better. Bound jumping. So there is a default policy, and we can get the policy. I don't remember which policy get. And then the policy ID. Okay, I lost it. And then you get a long JSON with the rules. But for example, I would like to show that in the this is how it looks, though. That, for example, in this case, it's still this allows having the port 222 defined in the Docker file. It also checks that the health check is there, and if the port 22 is there, it means that it doesn't allow it all. It warns if the health check is not there. And then in the end there is that it doesn't allow vulnerabilities that are greater than medium. So that is how the policies look. And then let's check the policy report for 3.7. This was the one that had something. And you can see that, okay, now in this case the report is the same. From these packages are the same, so that as we saw, and then there is okay, that health check is missing. So in the end, I would prefer Anchor compared to Claire if you like just getting started, because it's easier to use and there is more into it, so you can play with all these. And then there is 3 different modes. For example, you can. Yeah, I think I will have time to show one more, and then I will show this inline scanning. And then, because in a Claire and Anchor case, we use this push to engine, sort of. So we push that, okay, check this image. but there is also, you can just give a registry to Anchor and it will scan all the images. And then you need to go to Anchor and check the results. But this inline scanning is such that it actually starts a Docker container that runs the Anchor and then does it inline, so you actually don't run the service, but it is started as you go. But this Docker container is like 5 gigabytes because it contains all the vulnerability information. So the next demo is GitLab. So now we have actual build, and then we add an Anchor scan to this build, then we report, and if the report is fine, then we publish the image. There is no deploy phase. I was going to put Kubernetes there, but I didn't have enough time. So I have here a repository with code, and here in another window I have my GitLab, and this GitLab is running in Vagrant in my local laptop. So let's check that. Let's first put here the broken one, 3.67. If we put 6 here, it will pass, as we know. And then we will commit. To 3.7. Root. And now, I don't know how familiar with GitLab, but now it automatically starts the build. This will take about 3 minutes, and while it's running, we go to Files and check how it's integrated. So this is somehow similar as the Azure DevOps demo we had in the last meetup. So this is a usual concept nowadays that you have this CI/CD file. And GitLab has also this YAML file where you define the build or the whole pipeline. Build and these are not that, exciting, because it's basically running Docker build, inside Docker, didn't build. And then we have the scan. So here we do the inline scanning. So we use this inline scan image that is like 6 gigabytes, and then we go inside the image and then run one command, and it will do the scan inside of these 2 containers that we have here. The good thing in Anchor is that there are better examples for integrating with all the tools compared to Claire. Yeah, I have other things to say about Anchor in the end. So, and then the reporting, the first one prints out the report with this RF flag, and then we read the report here, and checking the JSON, we check that are there more than one vulnerability, or even, this will fail even if there is a single vulnerability found. And then we push it to the actual latest tag when it's finished.
So you push even if you find vulnerabilities?
It is pushed in the build as with the hash. The tag is like, I can show it. Maybe it's easier to show from the pack. It's used from the registry. This is the GitLab internal registry. So we have these build tags with master and then the git commit hash. It will use these, so it will push here first. Then it will do the scan using this one. So the Anchor will get the image using this from the GitLab registry. And in the end, when the report is fine, then it is pushed here.
So
That's the latest.
Is it based only on the report, or you can connect it to database to actually get the history change?
Yeah, we could, if you mean that we could contact the Encore and get the results, or
So like there is a result history.
yeah, there is. Yes,
report.
yeah, that could be. Yeah, that's the another. That's a good point, because now I'm using the inline scanning, so there is no actual Encore running. So it is started when the build goes, and then it's teared down. But if we would have Encore somewhere, then we could do so that we say to Encore that okay, now we have a new image ready, please check it, and then we could check it straight from the. Okay, maybe even if we build a good enough script, also the return code could say that okay, now it failed. But yes. Actually, the inline scanning does it also, so that it first puts it there and then checks the results. But it's also already, or everything this is put in a one single script. Okay, let's check if we are done. So we can quickly check the logs. So this is just a basic Docker build, as you can see. Then the scanning. There is not much to see. There is just status analyzed. Woohoo. And then we go to report, where we had our bash that said that one or more vulnerable packages found. And there is the same muzzle as we had before. And to prove that this works, let's change it back to 11. Okay. Yeah, I pushed it. Another build started, and we can check the result from the previous one. That it was able to push it. So now there is no vulnerable packages found. This previous list is just a listing of packages installed there.
Wouldn't you, in like best case scenario, in a way, use the registry scanning plus the inline?
Mm-hmm.
If you have some containers which are running there, like for a month.
Yeah, that's a good point. Thanks. So. Yeah, you can ask if there's something else, but I would also jump here, because that's one of the things that now I showed that how do you integrate in the pipeline, but that's very good finding that you probably also have some applications that you just push into production and then you don't change them. The pipeline is not run daily or weekly, so you need something to scan the registry and to inform that okay, now I have something in the production that has vulnerabilities in the packages. So yes. That's something that needs to be added into the mix to get better coverage. Yeah, please.
There's also some tools, can't remember the names, but they act as sort of a admission controller in Kubernetes. So they basically check that okay, you're deploying a pod with this image. They validate that how many vulnerabilities that images have, and basically say that okay, you're not allowed in.
No, but if it's running already, in that case, like it just.
Yeah. But when you configure your cluster with that sort of an admission controller, you can't get anything in.
But some vulnerabilities are found afterwards.
Mm-hmm.
That's usually the case.
Yeah.
True.
I would guess that they can analyze it afterwards too. I haven't.
And kill your app.
Of course.
Yeah.
There's no vulnerability if it's not running.
Yeah, this admission control, I think, I see it as a part of this policy management. So that's one way to enforce the policy that okay, only these containers are allowed. But yeah, still the case that if something is running, that also needs to be found. Yeah, and now I'm already summing up. So the Encore, as I mentioned, it has more features. but the Claire is simpler, or the Claire is simpler. It depends on the preferences. If you are, for example, building a pipeline that requires only this OS package scanning, I would pick Claire. But if you research something, the Encore is better choice. And there is also the one thing that I'm a bit always, I have my doubts, is this Encore is a product of a startup, and that means that it's also rapidly evolving, and also that they are not, if they do something very great and fine, it's not going to be the open source. So they are always pushing that, okay, this is the core, you can use this, but if you want the actual features, then you need to contact the sales, and the documentation is somehow lacking. But in any case, the Encore documentation is good. And I would say that Claire documentation is not that good, but that's also because the Claire is more like tool, not ready-made solution. Okay. Then just to mention that here are the links. This blog was inspired by Stephen Ackerman's Kubernetes blog that has the same findings about the containers. I wanted to give this talk just to emphasize that to me this was eye-opening, and this was also a very nice research project to get deep and check how for example, Claire works and Encore works. And the main message is that when you enable such tools, or if you use the easier container scanning tools, it's good to understand how it works before you use it. So thank you. Any comments, questions? Or any more?
Did you try any other tools for your comparison?
In this case, no, I didn't. Yeah. In fact, I have forgotten all the other alternatives that I checked. So I don't, yeah.
How about vulnerability scanning for your own code? So this is
Yeah.
vulnerability scanning for others.
True. Yeah. So as I here mentioned that now we only discussed about, no, wasn't even library scanning. It was more about prepackaged dependency scanning that we discussed. But yeah, if you think about the whole picture, then you need to have a tool for code scanning.
Which are not these tools.
Yeah, they are not these tools. Yeah, you can have this in pipeline, but in a sense it's quite late if you get it only in the build that, okay, now this is failing. Okay, it's a usual convention nowadays that you test in the build phase, but I would preferably have the check in your local setup instead of always pushing it to somewhere.
I think Snyk does the whole thing.
Yeah. They have a product. I know the page and I have researched, but I haven't tried the product.
Oh, me neither.
Yeah. Have you tried any other products that could be good?
Yeah, we're using Black Duck.
Oh yeah, sure.
And that,
commercial.
Yeah.
Yeah. Yeah, that's one. Yeah.
I know about Aquasec and Twistlock and
yeah, yeah, true.
There's actually quite a few of them.
Exactly.
Yeah, and I would say that if we go to the, for example, code scanning and more the advanced, there is no open source solutions. That's my view.
Yeah, for example, we do it in a lot of states. So we scan, for example, code with SonarQube.
Yeah.
And then we have other things, and then that's for the code, and then we scan the container with something else. We scan even the whole solution with
something else.
Like what is that? Codenomicon and things like that. They make also this kind of like denial of service attack type of.
True.
But a lot of those are open source or free.
At least OWASP has the container which can scan for the top vulnerabilities. So that's which is open source. And
Do you mean in this case code scanning or dynamics?
For your own vulnerabilities.
Dynamics. Yeah. I think there is also the dynamic scanning solution. I don't remember the name.
Microsoft has credential scanners also. So
yeah, true. There are a lot of alternatives, but it's
exactly.
I think the current status is that you need to mix and match, as you mentioned there, that you need to mix and match all these to get. And currently the coverage for open source solutions it's probably there in the middle. But I'm also learning, so please give a next talk about this topic and let's learn more. Thank you. Anything else?
Okay.
Okay, thank you.
Thank you.
Okay, so as I mentioned, probably second week of April will be the next meetup, but you will get informed. Thank you for coming.
Thank you.